3.7, day number 1, the chain rule. Today we're going to learn the derivative of a composite function called the outside-inside rule and repeated use of this chain rule. The chain rule is most widely used differentiation rule in mathematics. So ddx is an operator like adding, square rooting, etc. And it means to take the derivative with respect to x. If we change x a little bit, how does the function, the y value, change, right? So it's just a rate of change, or the ratio of two changes. So let's consider the derivative of this thing right here, x squared minus 3x plus 4 to the 60th power. We certainly cannot expand it, so it would be terrible if we tried to. So we need another rule. So what you do is you take, you just kind of consider this like one variable. And so consider it power rule, right? So if I use the power rule, I would bring that 60 down in front and leave the inside how it is. So this is the outside part of the outside-inside rule. And what that would become is 59 here. And then we're going to multiply that by the derivative of the inside. So I didn't really leave myself much room, but I would multiply that by the derivative of the inside, which would be 2x minus 3. And that would be the chain rule. So you work yourself outside in here. So looking at example 1, right, the outside function would be something to the 6th power. So the derivative of this would be 6 times this thing, 2x plus 1 over 3x squared plus 2 to the 5th power, times the derivative of the inside. Now the derivative of the inside I'm going to need the quotient rule for. So I'm going to go ahead and do that off camera. I'll be right back. Okay, so you can see my work on the quotient rule here, where this became this piece of things there. So I'm going to clear that out. I'll be right back. Okay, so I did a little bit of work here. Simplified combined like terms here. Distributed this 5th power to both of these two terms, numerator and denominator, combined like terms as far as I could, within reason, and I get my derivative there using the chain rule. Okay, whoops, that was double lightsabers. That's cool. Let's take a look at the next example. So outside function, looks like I'm going to have multiple chain rules going on here. So the derivative of the very outside function would make this 8 sine to the 7th power of 5x to the negative 9th minus 8x squared. Now let's make our way into the next level, right? So this is our outermost function. Our next function is going to be the sine function. So now we're going to take the derivative, ignoring the 8 and the 7. We're just going to take the derivative of sine of all that stuff on the inside. So the derivative of sine is cosine. So then I would get cosine of, oops, that's a 5x to the negative 9th minus 8x squared. And then the innermost function is that function there. So we'd multiply it by the derivative of that, which would be negative 45x to the negative 10th minus 16x. And that would be chain rule. There's not a whole lot else we can do. We could try to clean that up a little bit, but for the most part, that would be it. That's double chain rule now, where we've got multiple embedded composite functions. Okay, calculating derivatives at a point. Let h of x equal f of g of x. Use the values in the table below to calculate h prime of 1 and h prime of 2. So first of all, what would h prime of x equal? Well, that would equal, right, that would equal f prime of g of x times g prime of x. So if I want h prime of 1, I'm going to plug a 1 in here. So I want f prime of g of 1 times g prime of 1. So h prime of 1 would equal f prime of g of 1. Well, g of 1 is x. G of 1 is 2. Okay, so I want a 2 there. And g prime of 1 is 3. So I got a 3 here. F prime of 2 is 7. So I'm getting 7 times 3, which is 21. So h prime of 1 would be 21. H prime of 2 would be f prime of g of 2 times g prime of 2. Let's see what this would be. That'd be f prime. G of 2 is 1. G of 2 is 1. And g prime of 2 is 4. F prime of 1 is 5 times 4 would give us 20. Okay, example 4, f of x equals cosine cubed of 4x, then f prime of x. Let's work our way outside in. Okay, so our outermost function would be that 3. So f prime of x would be 3 cosine squared of 4x. Next function in would be cosine, which would make that negative sine of 4x. Innermost function is 4x. Derivative of 4x is 4. Therefore, it looks like we would get negative 12, right, our 3 and our 4. Cosine squared 4x sine of x. Oops, 4x. That's a 4 in there. Let's see what we got here. Negative 12 cosine squared 4x sine 4x. That looks like our answer is B. Okay, here we go. For how many values of x will the lines tangent to the graph of that and that have the same slope? So we want to know where their derivatives would be equal. So we got some product rule work to do here. I don't know that we have any chain rule. Nope, not necessarily. So for how many values of x? Let's first of all find their derivatives. I'm going to do each of them. I'll do the first one in red. I'll do the second one in blue. We'll come back and we'll look. Okay, so I use product rule here. Now I want to know when these two derivatives would be equal, so I set them equal. E to the x times quantity x squared plus 2x plus 5/4 is equal to, let me use this color here, there we go, e to the x 1 plus x. So what you might be wondering is, well, why can't you drop the e to the x's? I have no problem with that. Okay, so now let's do a little work here. I'm going to bring everything to the left, so that'd be x squared. I'm going to subtract x from the right side, that gives me that. And then subtract 1, that gives me 1/4 equal to 0. Okay, so I'm going to multiply through everything. Multiply everything by 4. So I get 4x squared plus 4x plus 1 equals 0. I don't think I can factor that, so what I'm going to do is quadratic formula, x equals negative b plus or minus square root b squared minus 4 times a times c all over 2a. So let's see here, that'd be negative 4 plus or minus the square root of 0 over 8. Well, the fact that this is 0 means there'll only be one solution at x equals negative 1/2. So it looks like B, one place. They will have the same slope. Okay, I think this is our last example of the day, or of this lesson. Let f be the function given by this. Which of the following is an equation for the line tangent to the graph where x equals 1? So I want to know what f prime of 1 is. That'll be the slope of the tangent function. And then I need to know what f of 1 is. And what that'll give me is a point that I can then use. So let's first, I'm going to off camera find the derivative of f of x. I'll be right back. Okay, so I found the derivative. What you see in red there is chain rule. I had to do the chain rule on that, so that's the derivative of the first times the second. So derivative of the first times the second plus the derivative of the second times the first. So I just simplified to do that there. So now I'm going to find f prime of 1. F prime of 1. That'll be 10 times 1 to the 4th times 2 plus looks like 1 to the 5th. So f prime of 1 would equal, that's 10 times 2, which is 20, plus 1, which is 21. So I know my slope here of my graph will be 21. That eliminates a number of options. So now I'm down to a and b. Now I just need f of 1. So f of 1 will equal 2 times 1 minus 1 to the 5th times 1 plus 1. All I did was plug in a 1 for x here and here. So that looks like it'll be let's see, 2 minus 1. 1 to the 5th times 2 is 2. So now I got to do a little bit more work here. I know this point, I know that slope. Now I just got to plug it into slope-intercept form. So y minus 2 equals 21 x minus 1. That'll be y minus 2 equals 21x minus 21. So when I add 2 to both sides, I get 21x. Oops, that'd be minus 19. And there it is. B is our answer. That is 3.7 chain rule. Have a great day.